We'll give this one a go. New observations from the James Webb Space Telescope suggest the amount of ionized neon gas present in dusty planet-formed disks can tell us how quickly planets must form before the disk itself appears. Planets are believed to be born in a disk of gas and dust that swirl around newborn stars. Astronomers have observed these disks before, but the entire planetary formation process takes hundreds of thousands and even millions of years to complete. That means we don't usually get to see the disk change on small timescales. Rather, the feature just appear as snapshots frozen in time. Now, however, James Webb Space Telescope has observed one planet-forming disk changing quite substantially. In 2018, a team led by Catherine Espiliot, who was then the University of Michigan, but is now Boston University, used NASA's Spitzer Space Telescope to detect an infrared emission line associated with doubly ionizing neon. The signal was coming from a planet-forming disk ringing the young star SZ Cha. An atom is ionized when one of its outer elements is struck by high-energy proton knocked out of position by doubly ionized atoms, involving the loss of 2 electrons from the impact of 2 photons. When originally detected, the presence of neon in SZ Cha's disk was considered a rarity among disk types, or among disks specifically being bombarded by X-ray radiation from their young parent stars. Its existence actually implied that instead of X-rays, lower energy radiation in the form of extreme ultraviolet must be the dominant type of radiation field in the SZ Cha system. This sort of radiation is thought to eat away at all the gas and dust in the planet-forming disk, thereby breaking molecules apart. But it's not thought to disintegrate disks as fast as X-rays do. X-rays can erode a planet-forming disk 100 times faster than ultraviolet light can. Thus, the rate at which a disk evaporates, and therefore the amount of planets have to form within that disk before it disappears, depends upon the energy of radiation present. However, when Espiliot and her team followed up on the SZ Cha in 2023 with the James Webb Space Telescope's mid-infrared instrument, MIRA, they found the doubly ionized radiation had more or less vanished compared to the amount of singly ionized neon. This lack of doubly ionized neon implies that X-ray radiation, rather than ultraviolet, has indeed asserted itself as the dominant radiation field in the SZ Cha system. Ultimately, this finding could have big repercussions in understanding of how quickly planets must form before their disk dissipates. In computer models of developing systems, extreme ultraviolet radiation allows for 1 million more years of planet formation than if evaporation is predominantly caused by X-rays, says Boston University's Thanatholobi. Oh my god, these names in a statement. As such, the abundance of doubly ionized neon can be considered a proxy for the amount of ultraviolet versus X-ray radiation impacting a planet-forming disk in a given moment. By measuring its abundance, astronomers can better constrain the timelines in which planets must form within a system before their birthing disk dissipates. Complementary ground based on observations also found a piece of the puzzle. 2 Chiron spectrometers on the SMART 1.5 meter telescope to the Cerro Tololo Inter-American Observatory measured blue-shifted hydrogen alpha emissions associated with the star in the SZ Cha system. Blue shift is a Doppler-like shift that indicates something in the distant universe is moving towards us, in this case, hydrogen. Scientists interpret the situation as a stellar wind of particles emanating from the star, headed closer to our corners of the cosmos. The wind is thought to be dense enough to absorb ultraviolet light, but still allow X-rays through permitting X-ray radiation to assert itself over the evolution of the star system. The fact that doubly ionized neon was seen in 2008, but not 15 years later, in 2023, suggests the wind might be variable and perhaps related to what kind of radiation permeates from the star system's planet-forming disk. Further studies are now being planned, not only with the James Webb Space Telescope, but also other observatories covering different parts of the electromagnetic spectrum, to try to get to the bottom of what is happening in the SZ Cha system. Hopefully, This will help scientists catch the stellar wind fluctuations. We need to rethink, reobserve, and gather more information, said Espiliot. We'll be following the neon signs.